Okay, how to graph cosecant. Well, this one's going to be a little bit different. First off, let's think of this here. When x is 0, cosecant has 1 over 0, making it undefined, meaning I'm not going to have an answer right here, so it's undefined. Well, now let's think about that. So that means if I'm at like 0.5, I'm going to be way up there like at 114. As this asymptote gets closer and closer to 0, I'm going to get closer and closer to it, but never quite touch it. But what happens then at what I call the value would be pi over 6? It's actually at 2. And when I'm at pi over 4, I'm actually at the square root of 2, which is about 1.414. And at the square root of 3, I'm getting closer to 1, but not quite at 1. And then guess what happens at pi over 2? It actually becomes 1. Well, that makes sense. Cosecant has to be larger than 1, at least the absolute value of 1, because it's the bigger side, and the bigger side divided by a smaller side is always going to be bigger. Well, now what's going to happen as I move into quadrant 2? Well, think about it. I'm coming down like this here. If you think about your reference angles, I went from pi over 3 to pi over 3 is going to be the same value because cosecant is positive in quadrant 2, just like what sine is. And then at 3 pi over 4, it's going to be 1.414. At 5 pi over 6, it's going to be 2 again. And then as I get to pi, it's going to get infinity, which means my other numbers are going to get closer and closer to infinity as we get close to it, but never quite hit it. So I made this nice U-shaped parabola. All right, now then, that was just the bell in case you're wondering what happened here. Now then, what I got to do is I need to look at the other side here. Let's go to this quadrant here. Well, if I hit negative, and I'm real close to this right here, negative 0.5, I'm going to be the same value I have here, except it's negative in this quadrant, right? Ooh. So what happens at negative pi over 6? Well, that's going to give me 2, negative 2, as an answer, because it's like negative 1/2 flipped upside down for the sine part. So it's negative 2. Well, at pi over 4, it's negative square root of 2, or negative 1.414. And then at pi over 3, negative pi over 3 actually, I'm going to be getting closer to 1. But when I actually get to negative pi over 2, I'm actually at negative 1. Wow, and just like up here it did this, guess what's going to happen right here? As I move further away, the values are going to actually be the same, just negative. And I'm going to make an asymptote over here. So look, I have this nice parabola that's positive and one that is negative like that. So that's kind of neat. That's what a cosecant graph looks like. But something I kind of want to show you. Think about this. Think about your sine graph. Ooh, looky here. Looky there at sine. What do you notice about it? See right here where there's asymptotes. Whenever the sine hit 0, there was an asymptote. And where the humps were, we hit that. So let's look at it. So here we have this right here. Notice where it hits 0, we had some asymptotes right there. Like right there, maybe if you merge it up, we hit that spot right there, too. So the easiest way to graph a cosecant graph is to graph sine. And wherever the sine hits 0, make an asymptote. You can see one right there. It's hard to see the one that showed up right there, but there is one there. You can barely see the one here and barely see the one right there. And wherever those dots are, those are the humps. This is where it was positive, so cosecant was positive. Where sine was negative, cosecant was negative. And this is what one would look like if you graphed them over a longer period of time. It would look like that because it would just keep repeating. So the cosecant graph makes parabolas basically starting with an asymptote at 0.